We've talked about synthetic division helps us factor or find the zeros of some polynomial function that we otherwise don't have the means of doing. And that's what I want to get into now is how does synthetic division allow us to find the zeros of a polynomial function. And the best way to do it is let's just start with an example and I'll walk you through how that works. So it's going to be worded a little differently than the previous lecture. Now we're going to say solve the equation for x. Now when it says solve the equation for x, that means the same thing as finding the zeros, finding the x-intercepts. So I want to solve this equation for x, or find the zeros. 2x cubed minus 3x squared minus 11x plus 6 is equal to 0, given that 3 is a 0. All right. So what I want to point out to you here is this looks like something that we may be able to attempt to factor ourselves by using factor by grouping. Make this group 1, this group 2. I encourage you to try to do that. The issue you're going to run into is you're never going to be able to make those parentheses the same once you get a couple steps down from here. So that's an issue. We can't do that, so this is where synthetic division comes into play. These are going to be our coefficients that we're going to plug into the synthetic division. And the only thing difference here between the previous examples is now I'm telling you that 3 is a 0. This is what you plug into the box. So instead of setting x minus 3 equals to 0, now I'm just outright telling you what to plug into the box. And then this is 2, negative 3, negative 11, and 6. Okay, pause it and give it a try. Practice, practice, practice. Bring down the 2. 2 times 3 is 6. Add down, which is 3. 3 times 3 is 9. Add down, which is negative 2. Negative 2 times 3 is negative 6. Always add down. And I want to pause for a second. What is that number going to be there? 0. There. So this is my remainder. Remember, you start on the far right. This number is always your remainder. So that's odd. I told you that 3 is a 0. So what? And then you round up with a remainder of 0. And that's exactly what we're looking for. You're looking for the zeros. If you can run through this synthetic division process using your coefficients here, and then you just plug in random different numbers into this box, run it through synthetic division real quick, and out pop, you want to find all your zeros. So this is something that's automated real easily nowadays through, you can use it in Excel or any computer programming. You can automate something like this very quickly and go through hundreds and hundreds of these real quick. So for this example and the next example, I'm going to be giving you what to plug into the box, but later on we're going to get into where I don't tell you what the 0 is, so there's a way to figure that out also. So this is handy. Now we have a remainder of 0. We know that 3 is a 0. It crosses the x-axis at that point. And let's finish this. This is c, x, and x squared. All right, and so 2x squared plus 3x minus 2, and then I'm going to erase this so you don't have to write it. Plus 0 over, well, anything 0 on top is just 0. So now we don't have to write that remainder portion anymore. We're left with 2x squared plus 3x minus 2. But we have to keep the goal in mind. The goal in mind is to solve the equation for x. So I want to know all the x values that give me 0 in the remainder. I found one of them, it's 3, but I need to find all of them, and I have to keep using this to find the other ones. So you'll notice that 2x squared plus 3x minus 2 equals 0 is something that we can use prior knowledge to go ahead and calculate. And that's using the AC method. And I'm just going to jump to give you the answer. Again, if you need help with AC method and factoring, please go to the math lab and get some help. Do what you need to. Look up other videos online. So when you factor this, what you get is 2x minus 1 and x plus 2 is equal to 0. And now you just you break these up and separately set them equal to 0. Add 1, so you get 2x is equal to 1. And divide by 2, x is equal to 1/2. So 1/2 comma 0. And it just says solve the equation for x. So it's not saying find the x-intercept. So you can leave it there if you want, but I would accept either answer. I understand what you're doing. And then over here, x is equal to -2. All right, so it's real easy to come over here and circle these as your answer, but you'd get it wrong because you have to remember to include this initial 0 that I gave you. See, 3 is a 0. So and x is equal to 3. So make sure to include that one in there.